Welcome dear students. So today in this lecture, we are going to see the thermodynamic properties. The thermodynamic properties are defined as the entities which define the state of a system. Just like the example of ice or vapor for water, the state of the water will be defined by the properties of water. So these properties are divided into two categories. One is the intensive property, another is the extensive property. The intensive properties are those properties which are independent of mass or extent of the system or size of the system. Suppose for a small vessel, if the pressure is P, then if some masses enters to the system, the pressure may remain P. So it is independent of mass of the system. Suppose the room where you are staying, so it would be having one pressure. So if you enlarge your room, then the pressure value may not change. So that is the characteristics of that property: pressure, then temperature, density, surface tension, viscosity, thermal conductivity. So all these properties are called as intensive property. There are some other properties also, so which are not listed here. So I can write here this etc. So one thing you need to be very much careful in writing the symbols for the properties, that you need to use capital letters to show the intensive property as well as the extensive properties. So as because these properties are independent of mass, so when the system collapses to a point, the value of these properties does not change, or in other sense you can say they will reach some finite value. So just like that, this pressure, temperature, this density, all these properties under intensive properties are defined at a particular point. The second properties are the extensive properties. These properties depend on the content or mass of the system. So if the mass is doubled, so there will be an increase or there will be a change of the value of that particular property. So for example, so volume is one extensive property, then internal energy, enthalpy, entropy, electric charge, magnetization, potential energy. So all these properties are extensive properties. So this internal energy, enthalpy, entropy, all these things are newer to you, but during due course of time, so all these things will be clear to you, because in your undergraduate syllabus, this undergraduate course, so we are having all these terminologies. So here this is written in note that intensive and extensive properties are denoted by capital letters. and in the bracket also you can see. So I have written all these properties by capital letters. For volume, capital V; for internal energy, capital U; for enthalpy, capital H; entropy, capital S. So like that we have written. For density it is rho. So rho is the specific symbol for density, so it doesn't matter whether it is capital or small letter. So one special property is there which is called a specific property. So it is the special case of intensive property. So as because the intensive properties are independent of mass, so here the special intensive properties will be dependent on the mass of the system. So it is the value of an extensive property per unit mass. So for writing these specific properties, so we will be using the lowercase letters. So here you can see, so volume, it is an extensive property, but specific volume, so it will be the intensive property. So now this particular term which is denoted by small letters or lowercase letters, so will be independent on mass. Earlier volume was dependent on mass, now it is independent on mass, because per unit mass term it is given. So volume, it is extensive property, so per unit mass, so then it will become specific volume which is intensive property. So for internal energy also, as because internal energy, it is dependent on mass, so this specific internal energy, it will be independent of mass, so divided by m, extensive property divided by this unit mass, so it will be one intensive property. So for enthalpy and entropy you can see, so small h is for specific enthalpy and small s is for specific entropy. Okay, so here you need to remember some of the important points. So these points are that specific extensive properties are intensive property, I have told you already. Then as because there is no dependency of mass for intensive properties, the properties are defined at a point. So these intensive properties which are independent of mass, so are defined at a point, just like we define pressure, temperature, then other intensive properties defined at a particular point. Because just like the definition of stress, so what is stress? So stress is load divided by area. So when area tends to 0, the load, the pressure or the stress is having one finite value. That is why we define stress at a particular point. So just like that, so we define pressure, temperature, all those parameters at a particular point of a system. So always remember, all these pressure, temperature, all these intensive properties are defined at a particular point, and those properties will define the state of the system. Okay, so now let's come to the state of a system. So state of a system means, so whether it is liquid, whether it is gas, whether it is in solid state, so those are called as state of the system. So the specific peculiar characteristic of these states are the properties which will define the state of a system should be uniform throughout the system, as because we are studying macroscopic approach. So when we have defined the macroscopic approach. So I told you that here the study is not in molecular level. So on depending on the behavior of some average molecules, so the properties are studied and average value of the properties are taken. So that is why the average values of the property should be uniform throughout the system to define a state. And the second important condition to define the state of a system is that the properties should be invariant of time. To have a liquid state for a particular substance, so there should be some time duration, isn't it? So to have all the properties a definite value, all the properties should possess the definite value for a particular amount of time. Otherwise all the points, all the states, okay, all the states or all the points of the particular system will be dynamic, isn't it? So to get a state of a system, so the property should be invariant of time for at least for a temporary time period. Okay, so two things. One is the properties should be uniform throughout the system. Then the properties should be invariant of time. Just like the ice state, that solid state. So the ice of the temperature of ice is below 0 degree centigrade. So as because it possesses 0 degree centigrade for particular some time, then that is why you are getting that ice. Otherwise it will be melted to, or it may be vaporized. Okay, so these are the two basic criteria to have a state, okay, or to define a state. Okay, thank you students for listening.